Okay, so I've got the motor now mounted roughly where it's going to be in the Land Rover. Traditionally, that motor was mounted at the back of the car. I am now having trouble. I can just connect that main plug to the harness for the motor, but there's also this one here. See, this is usually mounted on the rear subframe at the left hand. So the wiring harness is plugging in back there. The plug I need to get to is here, so I'm having trouble reaching it. So I'm going to have to start going back into the wiring harness to relieve those wires so I can get that back further. Yes, it looks, that's why I don't like unwrapping it if you don't have to, because it starts looking like a rat's nest. It's fine though. So this plug now reaches. We have success. Lengthened the white charge port controller and cut where it's ground in there. Here's the new ground, just to go to chassis somewhere. So I'll just join it to my temporary grounds in here. I'll do it better than that. Yeah, and that'll get things up and running. Okay, a bit of a moment of truth. Reconfigured penthouse and battery have all been done, so that's a big job. I think everything's hooked up again. The hardest bit is getting the grounds. I've filled up the coolant using a vacuum filler to try and get out any air. Put the battery back in, haven't put the negative on, that's the last thing. So, time to just connect it and see what happens. Could hear a clunk. Like any good project, problems are sort of inevitable. Pumps are gone, there's no contactors clicking though. Have I left out a high voltage interlock? You will have seen in my previous videos reconfiguring the Tesla Model 3 battery and high voltage system. I wonder if I've got the correct earth on the penthouse. So I've done quite a lot since I last had this up and running, so it's not overly surprising that something's not quite happy. Charge port open, interesting. I don't have the charge port door connected. So it obviously didn't connect the main contactors, because you'd hear the big clonk. So, what have I done here? The motor's there. So I installed the charge flat back onto the motor, and it was in the totally open position, so I've had to push it around, and it clicked around in there. So hopefully that will give the signal that the charge door is closed. Still no contactors. There we go. Well, the charge door is working now. Red. Interesting. Charge port open. So, I'm going to guess maybe high voltage interlock or the high voltage controller grounding or something. More investigation is needed. Okay, so it's turned on. I did the switch to simulate the door opening. Charge port latch fault. AC charging reduced. DC fast settings may be unavailable. Charge port latch fault. AC charging reduced. Sometimes problems are complex. Sometimes problems are caused by something dumb that you've done. This particular one is one of those. Okay, so my charge port needs to be reconfigured. That's alright, we'll sort that out. Okay, obvious problem. I haven't plugged the I don't even know what it's called. It's the little motorized pin that goes and holds the charge plug in. I better get it wrapped from around here. So that's why we're having the problems. Right, so I'm hoping now when I connect it I'm going to get a clonk from the contactors. No clonk though. PC front A192. Yeah, I reckon I got that same error when I didn't put the top on the penthouse. So fairly sure it was that one, which I have grounded. Maybe it was that one. Anyway, I'll have to look at that. Zero. Not connected. So I think I found the problem. So I'm probing the high voltage interlock here, and there's no connection between them. So that's my problem. So the high voltage controller is expecting this circuit to be continuous. So it comes out here, goes through the front drive unit, through the cables, through to the rear drive unit, connects through there, then goes through the other high voltage, which is the heater and the air conditioning, and then comes back in pin 7 and pin 24. So yeah, so if you measure with the meter and everything's connected properly, it should be connected, but it's not. You can actually see the interlock is in this cable here. It's just a connector to these two pins here. It's just literally just a bridge. Alright, so I've plugged that plug back in, and with probe on each thing, and they're not connected again. So I'm wondering if, I don't think that H-fill is connecting, or that plug's not going in properly. Might be because of the thickness here, but I'm just going to bridge the H-fill to double check that. So I've just bridged those two pins. Yeah, oh yeah, we got connection again. There we go. So this plug doesn't seem to be going in all the way. Yeah, I'm wondering if the thickness of the case here is causing the problem. So with that interlock bypassed, it was time to test and see if the contactors would close. The audio in this video clip was corrupted, but I can assure you the contactors did close, and that seemed like it had solved the problem. The car still wasn't happy though, and after about 20 seconds the contactors would open again, so there was something I had to sort out here. It was at this point that I realised that I needed to use the Tesla diagnostic software called Tesla Toolbox. A friend and I had been planning on hiring it for a little while anyway, so now was a good time to use it to try and diagnose the problems I was having. The main error I needed to really get onto was the high voltage isolation error. This is basically the high voltage battery not being totally isolated from the chassis ground. Isolation resistance 90 kilo ohm. BMS state fault. Interesting. Positive terminal directly on the battery to ground. It's reading 117 volts. Still getting high voltage. Unplug the PCS and that. Made no difference at all. After doing all sorts of measuring and testing, I finally worked out it was earthing through the metal hose clamp and through the rubber coolant line through to the chassis, which was sort of surprising. But as soon as I put all this orange insulation plastic on, it solved the problem. Next error I would tackle would be the BMB communication error. I'm just testing the continuity between, this is the connector that goes in the high voltage controller to the BMB, battery management board. So yeah, it goes from here to there. I sort of feel like I've been a bit of an idiot using my fine multimeter probes to test stuff at some stage. Sorry, they're not fine enough really to use for this. I'm wondering if I've jammed them in there or something to test them and stretch the pin so it's not making contact anymore, because I'm doing a test here. I've got it in there. I'm now using solid Cat5 cable for this, which is a much better idea. I've got to remember that in the future. So if I test here, the continuity, I'm not touching the pin, I'm just touching the wire side. Oops, God, is This is easy without a phone. So yeah, got continuity through the wire, but I'm not touching the pin to the B&B, battery management board, which you can see just in the middle there. If I touch that, no continuity. If I touch the thing, or if I jam this in, then you can see the gap in there. I reckon that's my problem there, definitely. Focus. Focus, man, focus. So I've bent them in. I think that's actually going to be alright. So that's going to make much better contact now. So yeah, let's put that in. So, flood sensors. These are the flood sensors here. So I originally just mounted these at the bottom of the battery pack, and the problem is I didn't mount the flood port under them because I didn't realise this was an important part of the actual flood sensor. I thought originally that all this did was, you can see in there a whole lot of, I don't know what they're made of, they're like little expandable pieces, little expandable discs. A bit like, you know, when you get a bit of like MDF or something, that's it, and you expose it to water, it swells up. These do the same thing. So if water gets in here, it swells up, and basically they all expand, which draws the whole flood port down and opens it up and would release any water in there. That's the only thing I thought they did. But this bit here, the end of that there, that's a magnet, which is important for the flood sensor, which I think is just a Hall effect sensor, which measures magnetism. So if this swells up and moves down, moves the magnet away, and then the Hall effect sensor knows that, oh, where's that? It's reduced magnetism. I'll activate the warning to the computer. So these usually sit either side of the penthouse, actually not at the bottom of the battery, but at the back of the penthouse. So just to I measured the thickness of where they mount in the bottom of the penthouse case, and it's, what is it, 5 mil, I think. So yeah, this is just a piece of plastic that I've just made up and put some holes in just for testing, and so they'll fit up in there. And yeah, that has solved my flood port missing problem. So yeah, that's pretty cool. So I'll mount these, because of the wiring, I'm just going to mount them whereabouts down in there. I need to drill the holes still, but I'm going to have to wait until I've got the battery out and everything to do that. But at the moment, that has solved that problem. So the car now boots up okay, the contactors close, but there's something weird going on with the PCS. Are you supposed to make that noise? It's quite sweet, actually. Little birdie. Let's see. Need to read some vitals. What? I don't think my warranty is going to be valid anymore. That's a shame. Oh well. So we're into the guts of the PCS. So we've got the AC, 3-phase AC input from your EVSE that goes in here, and all the fuses are populated, unlike the American ones which only have single phase. Right, so that's all the AC input side of stuff. This is the high voltage battery input, and this is the 12 volt DC charger, which Takes this, converts it into 12 volt. So I'm wondering, I need to test these fuses to make sure that they're okay. This is the first obvious test. Let's do that. The fuses all tested fine. I also tried different things in the Tesla toolbox to try to reset the PCS, but nothing really helped. Sometimes it would intermittently be charging the battery on and off, and other times it would just stop and fail any charging of the 12 volt battery. I managed to source another PCS and actually the whole penthouse components from another Tesla tinkerer, so I thought, well, replacing the PCS is the next logical option. So Pyro's back in, it's all connected back up, connected the battery. Contactors closed briefly, then opened again, and that's because that PCS hasn't been paired. It's got a different firmware on it, which is confirmed here. It's the gateway PCS, power conversion system version mismatch. So pretty sure then the CAN redeploy will fix that. So I'll do that now. Currently working. It'll take a little while. Interesting. It's making the same weird sound as before. I was a bit stumped at this point. This was the sort of thing I was sort of having to leave and just scratch my head and think about for a while. A weird twist of fate occurred at this point in time. I was contacted shortly after this by a guy I'd been speaking to earlier who was doing basically the same thing I was doing but into a VW transporter. He wanted to see if I had any ideas on a problem he'd been having with a beeping PCS. He described the exact same problem that I was having. Obviously I had no idea what the problem was, so I couldn't help him, but sort of comforting knowing someone else was in the same boat as me. In the end, he managed to sort the problem and help me out. Okay. So I've gone through and redone all the ground wires. Put a big thick one back to the PCS. I feel like I'm making progress. I've now got PCS control. I've got no horrible noises. But to do that, I took Simon's advice and actually put a jump pack on the output of the PCS, which indicates to me, which was the same problem he was having, the resistance to VC front, I think, is the problem, as in, I feel like it's my ground wire back, because this usually goes straight into the body of the vehicle, which is, you know, fantastic ground wire. He solved his because his battery is all mounted and this is all grounded into the chassis. He put an extra wire in there and that made his PCS go quiet. So these just go back to the ground up there. Now just listen. Take them off. It's the same if I take this one off too. It gets really loud and stops charging. Now I've got this going, an extra one going to VC front, which comes in there. You can see the original one under there underneath, and this is the new one on top. They're all up and running again. Okay, now, so if I just try and plug this in, yeah, it won't go in because the latch, there's a little pin in there that needs to be released. I think I need to use this to unlatch it. Oh, and then the light comes on and it says on the screen charge port open. And starts charging. Stop charging, unlock the charge port and unplug. Then it should, yeah, door closed, and then latch goes in. So I've got my Tesla wall connector handle, and these have a button on them, same as a Tesla supercharger. That is, I think it's like a 433 megahertz radio signal. So if I press it, I can't get it. It's a long cable, but I can't get over there. But oh, it didn't work. It worked on Evie. Need a bit more. Got it. Charge port open. Got a pretty good range. This is about the limit. And then it'll just close after, I think, a couple of minutes. Don't actually need a charge. Let's see if I can put it into drive. Yep. Returning.